Ferry. So, hi Andreas, thank you for sharing the marvelous facade project. How to overcome the spontaneous tempered glass breakage triggered by NIS on complex facade structures in your projects?
Yeah, good question. I already answered it also in written here. No? So nickel sulfide in the end is something that you can control. No? So to a certain degree at least. So in the end, the question is the investor or the client of the building, is he ready to invest in high quality raw material, raw glass first, where the nickel sulfide content is kept to a minimal, A. B, does he use then a glass processor that is following certain procedures, meaning the tempering procedures, which is also, again, then reducing the risk of spontaneous glass breakage, meaning the duration and temperature of the tempering process and so on. And C, to have then a good and real heat soak testing done on the glasses. Now, I think you know what I'm referring to with real. There was a lot of, let's say, we call it heat soak test, but we save a little bit of money by not coming to the real temperature thing going on in the world. No? So if people really stick to proper procedures and use high quality raw glass for their products and follow all the processes and quality checks, you can minimize the risk of nickel sulfide breakage to an absolute minimum. And when we source the glass from our own Seele Group internal sources like Sedak or Sunglass, we can be very sure that no such thing will happen on site, and it doesn't. So it's a question of the readiness of the investor to invest in high quality goods in the end.
Yeah, there's no other way to do it, I guess.
Yeah.
Okay, next question for you, Andreas, is from Ramil Rivera. His question is, can we introduce an openable panel as a smoke exhaust, just in case there's a fire?
Absolutely. This is standard in many grid shells all over the world. And sometimes you can see even the spindle motors coming down from the panels. Whether they look good or not is another question, but there are also other ways to do it with concealed motors. Again, this is then a question of budget, because the concealed motors require more technical finesse in the design and in the fabrication to conceal them. So absolutely, yes. And the grade of quality, visual quality, how you execute it, then is a question of money again.
Okay, Andreas, thank you so much. I'll move to Sudeesh. I believe that you guys are using Outcrossing Method for combining the wind tunnel data with the wind climate model.
That's right.
Alan Davenport, who you referring to in your presentation when on the wind loading chain, and for who first came up with the Outcrossing Method, identified that his technique was not suitable for regions that were governed by non-synoptic winds, like those in much of the Southeast Asia, including Indonesia. May I ask how you guys address this in the Outcrossing Method you deploy? Or is a different method used for regions such as Indonesia?
Yeah.
This is an issue that sometimes comes up then when we're talking to various wind tunnel labs.
Okay, that's a good question. So the tropical belt is governed by, the design wind speed is always governed by synoptic winds. When I say design wind speed, it's a 50-year wind speed. However, you also have a lot of thunderstorms. So it's also a thunderstorm-driven climate, the tropics. But the beauty about thunderstorms are they are low return period events. The facades are typically designed for 50-year return period, but the thunderstorms are low return period and they are short duration, and they mostly impact low rises, not the high, tall towers. They impact the low rise structures. So what we do is we use upcrossing, of course, because the synoptic winds, the design wind speed is driven by synoptic winds, not thunderstorms, right? But for the wind directionality, of course, we have to be a bit conservative, because that completely depends on the quality of the data that we get in these regions. Indonesia, Jakarta, or Malaysia, or Changi, right? So if the data is sporadic, if we are missing data points that we purchase from the airport, then we have to be a bit conservative in analysis because of the thunderstorms. So there's a bit more analysis for these regions.
From Edwin Agustin, why is the wind tunnel result diverse from different wind tunnel companies?
Okay, that's a very good question.
Does it make sense?
The reason is, I mean, in fact, the Council on Tall Buildings and Urban Habitat, CTBUH, I think was it 2 years ago, to address this very question, released a guideline. I think it's chapters 4 and 5 for wind tunnel testing guideline. This is to enable engineers, developers, and architects to understand the different steps that are there in wind tunnel testing. And as long as you follow the same steps, the result should be the same. In fact, most of the wind tunnels around the world are designed to simulate wind at a particular model scale, typically 1 to 400. If you have a 40-story building, square shaped building, you test in any wind tunnel, the raw data that you get should be the same. But theoretically, but actually, because of the way different laboratories do it, there are differences. One of the main differences is the number of pressure sensors. So if you recall in my presentation, I said we can test up to 1,000 plus sensors. And for a typical 30-40 story building, you need 500 to 600 pressure sensors. If you reduce the number of pressure sensors, say for example, one laboratory does 200 to 300. So which means they have to make guesses as to what the pressure would be at a particular corner or edge. And guess means the results are conservative, right? So there are differences in results. And of course, in the wind climate integration techniques that they adopt. Those are the 2 reasons.
Thank you for that. Aibi, what are the methods for retrofitting of cladding to update the building to the new fire?
Oh, okay. So the first thing will be to understand what is actually there. So there is usually a first phase of digging. What is in the as-built? Can you find anything? Depending on how old the building is or how well the construction data was kept. Sometimes you find a whole lot of information, sometimes you find nothing. And so that is really your starting point to understand what is actually there and investigating, each of the materials to understand how far away, that building is from the current fire codes. And you would usually end up, even when you have the data of what was built, it's always beneficial to have some open up works where you go and do a proper site investigation, take out a few panels, do some, dismantling in a small area just to understand what is on the paper. Does it really match what was built? Because, many times it doesn't quite match, what was built. So you need to go back in there to understand what was there, what is there, what can be kept, what cannot be reused. And that would then inform your decision as to the level of, retrofit that you're going to put in. So we have cases where buildings have had to be stripped back, down to the base build. So it's basically the aluminium framing were kept in place. So if you're looking at rain screen system, for example, the aluminium framing was kept in place. So what was then taken out was the actual maybe ACM panel and the insulation, which was PIR or PUR type insulation. But we've also have situations where if it's a sort of light steel frame construction where you have a cement board in front of it, we've had cases where, up to the cement board can be taken out. So it really depends on what is there. So once that is identified, it then goes into a process of basically redesigning, if you know what is being kept, and also thinking about access. And I think the main challenge is bearing in fact that a lot of these buildings are actually live buildings. They're not empty sites, they're people's homes. So that is an added complexity. So it's the construction process also needs to look at that in the sequencing of how you create the least amount of disruption to the people who are living there, because suddenly somebody doesn't have any daylight because you have scaffolding and a mesh around the scaffolding in front of somebody's house, so you can't open your windows. And you can imagine if the temperature is very hot, you can't even open your windows for ventilation because there's a builder outside drilling drilling stuff. So those are the sort of considerations that, you know, impact what needs to be done. In the UK, what we typically do is everybody is involved. So it's your proposal for replacement. You know, the architect is back on board, the main contractor, whoever it is, the subcontractor to do the remedial work, the access strategy to get to the facades. The London Fire Brigade, the building control. We basically have to take it through the fire engineer. Everybody has to sign off, you know, that level of work, that, okay, this is what was built initially, this is how we're rectifying that. So all that hoops need to be, you need to go over all those hoops. So it's not the it's very sensitive, and it just needs to be treated with that level of detail.
Okay, understood. What is the effect on thermal break on the strength of the aluminium profile?
I'll put it very simply. Okay, there is an impact, and generally, in terms of design for structural performance, I think it's about 80%. But in details, there's actually a need to do, let's say, a structural calculation through the moment of inertia of the aluminum profile itself. And of course, there are also a lot of testing methods regarding the structural, let's say, structural performance of the assembled aluminum thermally broken profiles. So, for example, there are standards that actually take care of the shear strength and also the tensile strength. This is also simulating certain loads that, like wind load, structural loads that come in when the profiles actually are going through when they're actually built in a building itself. So I would say that in general, there are already standards that's established in place to help assure that the thermally broken aluminum profiles can be used for curtain wall facades and also for window systems as well.
Second question for you, Amos, from Pak Wawan Kusuma Satriawan. Thank you for the innovation for curtain wall. The question is, could we collect solar energy on curtain wall glass?
Okay, so
interesting.
No, I think this is an interesting topic. It's also a very innovative topic. I think firstly, I would say definitely yes, but actually there's a bigger challenge to just collecting energy through photovoltaics. I think typically we call this BIPV. The current problem or challenge that the industry generally have is that the aesthetics of the photovoltaics on the glass itself, and also the current aesthetics of the photovoltaics also preventing the visible light transmittance into the indoor environment. So these are two challenges that have to be tackled before I would say that the let's say facade paints can actually be using let's say BIPV. Of course, what we have also seen is currently there are also new technologies whereby they're actually bringing transparent BIPVs that are more or less translucent through very small solar cell dots that actually collect this energy, and then they are actually retransmitted to let's say energy battery and things like that. So we are seeing, let's say, the BIPV technology itself improving and dealing with the challenges that typically we don't want to see on our facade. So I think in the closer future, we'll be seeing more of these technologies. At the moment, I think there are some. I'm not sure of who are, let's say, pricier or not pricier, but in general, there are already some more innovative companies that already came up with, let's say, translucent solar cells itself.
Thank you for that, Amos. I have one final question to close off our Q&A round. This is for any of the speakers to share your thinking, your thoughts. The question is about integrating applications, code, and glass materials, which is suitable, construction safety, and market applicable. Also industries related as well, is everything in one. So briefly, probably explaining the process using the application to building models to suitable glass material, who is involved, what's the result on every phase, parties which are in Indonesia, market and consultancy, probably. So I'm trying to find the questions here actually. I think it's about integration of different stakeholders, codes, materials, safety, and also the applicability to the market. And then I guess maybe share maybe how about this? Maybe share your challenges from each of the speaker in integrating all those aspects into your expertise, if that makes any sense to any of you.
I mean, like this, it would become then a question about the usage of codes. I mean, that's certainly challenging. So what we normally do, we are engineering to European codes, and then we are cooperating with local structural engineers for the endorsement of our engineering again, which means the local structural engineers, they make sure that what we are calculating there is to the minimum applicable also, or fulfilling the local code requirements. So we always have to dance on two weddings at the same time. So, but that's a standard process here. But when we look at this question now from a stakeholder point of view, and how to bring all these stakeholders together in one project to make sure that the result is the best possible result, I'm always coming back to the client there. For me, the key is always the client and his commitment to his project. Because you can do that on a high level, and then again, there is a certain cost involved, or you can just try to get away cheap somehow, which then always leads to conflicts between certain stakeholders and their interests, and it will never come out with a real good result at the end. So the key of each project is the client and his own commitment to his project.
Yeah, I think that makes sense. I think for Sudeesh, the same school of thoughts apply. You're doing the, you have a lab testing, but then the set of regulations should come from the client, I guess. And then you will test toward that, or some international standard that applicable to the building or the environment, the region where the project is located.
That's absolutely right, because we have to conform to the established local requirements, and then there are international minimum requirements that we have to absolutely meet or exceed, right? The one driver, like for example, for a project in Indonesia, the one driver would be the actual local wind speed, right? I think it's about 32 meters per second, 3-second gust. That will be dictated by the local code, right? But then we use that. But then the rest of the information, like the specific site-specific wind speeds, all those things we get from the local airports, and then it's internal data, which is modeling and testing.
Okay, I think Aibi also already touched on this from your previous comments on how to basically doing the retrofit project, right? So there are a lot of stakeholders involved. There's the the residents or the space, the space occupiers, and then there's the set of materials that's already been installed that you need to assess. So, you know, any other thoughts that you want to share with us on this?
Yeah, so I think with the, as everyone has said, you know, there's a lot of factors you need to consider in the design of anything, be it retrofit or be it new build. With new build, if I just sort of touch on, so there's a lot of, say, logistics. Logistics affects what you can do or what you can't do, and the cost of it quite significantly. Looking at the 17-meter glass panel shared by Amos there, it's beautiful, you know, it's gorgeous, but you know, not everybody can provide that, and you wouldn't necessarily find that in every glass fabricator. So if your project is in a country or in a location where it's not going to be able for them to transport it readily, you know, that would take precedence as to, you might want the aspiration, but you know, the logistics are just not in your favor, because you could get it done once, but you also have to factor in that glass is a brittle material. It breaks. If that glass breaks, it's going to probably take easily 6 weeks, 6 months, you know, for that glass to be refabricated and sent down. So it's like you're going to have a butted up area of your facade. So all these things will affect sometimes what clients can and cannot do, you know, and there's always that impact as to what is the impact of, so for example, replacement is a big thing, because during the design stages and during the construction, you know, you've got your tower crane there, you've got all the massive, wonderful equipments there, and then, you know, everything is fine. You can install anything you want because you've got the gear for it. If, for instance, you know, 6 months or 12 months when everybody has left site, a glass panel on the topmost corner breaks, you have to factor in how you replace that panel, because you have to replace it one way or the other. And so all these, there's a lot of input into why certain buildings are done in certain ways, and has been touched on. There's the local element of what is allowed in the codes. Some things are allowed in Europe, they're not allowed in Asia, purely because of the climate, the considerations. So all that really factors into place, and everything, basically you have a checkbox of this is everything we wanted to do, and then gradually as you go down the design list, it will then whittle it down into and basically distill it into something that works for that particular building, that particular design intent, that particular aspiration, and whatever it is any other complexities that affect that.
Okay, thank you everybody. I think with that, I would like to bring the webinar session this afternoon to an end.